Now this illustration still deals with placing a piece of electrical equipment or switch gear, panel board, whatever it may be, into electrically safe work condition. Now notice this call out title head is placement, capacity, and impedance. In accordance with the requirements in 120.58A through B or B, just A and B. The purpose of the change, the text deletions and revisions make it very clear with the new wording that all circuit conductors and circuit parts are included. Uh, we should look at all the hazardous voltages coming in. Is there more than one? And naturally, all those hazardous conditions are to be included. Now, notice that this particular person in this illustration is using an extension tool, and he's placing these grounding conductors for safety. They're safety grounds in accordance with 250.2 through 250.4 on pages 44 and 45 of 70E. Now, with his moon suit on, he's standing probably well out of the limited approach boundary, using the tool and positioning the body as far as he possibly can, or she, from the equipment. And this is a large, a capacitor bank, say. And the flash chute, or the flash suit, protects from energy caused by storage energy that may exist. There may be some storage energy in there, or it could develop. But notice 130.7C 10A to 70E on page 31 addresses this moon suit. I call her the moon suit. It's a flash suit. But notice that this is a qualified person performing a task and wearing the appropriate personal protective equipment, PPE, to do the job in accordance with 70E 130.7C1 through 15. Going through C1 through 15, selecting the equipment that is needed to perform this task. And then, of course, the impedance of these conductors and so forth for grounding, 130.58C on page 23, as well as the ANSI standard, the ANSI standard, I believe it's F855, that would determine the size of these safety grounds based upon the cycles. Most of these are maybe a 4-alt. It could be, excuse me, I didn't mean to switch illustrations on you, but usually these are 4-alt. And they'll use a 4-alt. It's welding cable. Sometimes it's a mining cable. Sometimes it may even be a locomotive cable. But they're very flexible. They're more flexible than a regular conductor, and they don't put such a bind on these connections. And then, of course, you can connect them to ground. If it's an overhead ground, like from a cross arm, from overhead conductors, it's usually about 30 foot in length is what they suggest maximum length. Now that's a suggestion, just a recommendation, not a requirement. In a substation, they recommend about 40 foot. 4-alt works good, up to about 15 cycles real well. So keep in mind that a good 4-alt is a good safety ground to be used for the protection of personnel. So placement, capacity, and impedance of this safety ground for personnel is very important, and we'll look more into this as we go through. But remember, if this was on the wall, and right on the opposite side of the wall was the overhead lines coming in. Even though you de-energize with them whipping, they could energize these terminals here, lugs, whatever you uh, call them. And if you ground them out real good, then you know you're going to trip something upstream, and the current won't feed that arc for a long period of time. So we're always worrying about backfeed. So when the code says use safety grounds when necessary, that's when uh, you know, you can't tell if there's a backfeed coming into the equipment from somewhere. A UPS may be kicking in, a generator kicking in, fed from another substation. Windy days with if their overhead lines whipping and blowing them, and they have that whipping effect. These are reasons to use safety grounds. But I always suggest, and most companies suggest and require, that anytime you can, you use your safety grounds. But notice terminals, uh, uh, you know, any kind of clamps that you use, they are sized in conjunction with the conductors, and we use the ANSI standard 855, I believe it's F, that we would use to accomplish that. Now, as I pointed out, if you look at our 70E workbook, then we have tables in there that those calculations are already made on number 2 through 4 alt, based upon, I believe it's up to about 60 cycles clearing time, with different amount available short circuit current appearing that they would be capable of clearing. So hopefully, though, this information here now is helpful to get us started, that were these conductors for grounding, for the safety of personnel, placement's important, the capacity, the amount of short circuit current they would carry, and the impedance of these conductors to allow short circuit current to flow through them to ground. And that's what this illustration is trying to point out.